All right, so in problem 5 here, we're testing the labor force differences for women in 19 randomly selected cities in 1968 and 1972. So um, these cities, for instance, you look at New York in 68, New York in 72. You look at Chicago in 68, Chicago in 72. So they're paired data. So the samples are not independent. Okay. So in this case, we're going to look at this top result right here. And our null hypothesis here would be that the mu of the difference would equal 0, and the alternative would be that the mu of the difference in this case is greater than, no, does not equal 0. Does not equal 0. Okay. And that's basically right here. Okay, so that's basically written for you in the second line here. So what does that mean? Our p-value, our big p-value is 0.0244, so we're going to reject the null. So we're going to accept the alternative that the difference, the mean difference, does not equal 0, so there was some change in the labor force. Okay, so the second question is, well, that's basically it. So basically we use a pair test, and we would reject the null, and we would determine that there was a difference in the labor rates of women from 1968 to 1972. Value is 0.0244. So if we are testing at the 0.05 level, we would reject the null, right? So the null would be that, let's say, the null would be that mu of 68 equals mu of 72, and the alternative would be that mu of 68 does not equal mu of 72. So if we reject the null, we accept the alternative. So if we accept the alternative, then what are we accepting? Well, we're accepting the fact that the labor participation rate changed from 1968 to 1972. Now, 0.022, that's p-val, is not, I wouldn't say there's strong evidence, but there definitely is evidence. It's definitely below 5%. So in this case, we would say there is evidence of a change in labor rates for women between 68 and 72. So we would definitely reject the null there.